Hi there, and welcome to the 8th class of the Archimedes Academy by IMSystems. Last lecture, I was finally able to explain to you the working principle of the Archimedes Drive and its advantages and disadvantages. This was on a quite technical level, but if you are really going to buy a drive, you typically look at less technical properties. And I want to give you a whole list comparing it with the conventional technologies, and I will do that in 2 classes from now. But first, you need to understand that traction is something completely different than gear teeth hooking into each other. And therefore, a straight-up comparison with some numbers doesn't explain the whole story. And I want you to understand the bigger picture. So I will go over some properties, this and the next class, that requires some more attention to really understand how you select the drive best. And you will also see that there are some unique properties to traction that you will never consider if you buy the drive with gears, but that are smart to keep in your mind when selecting drives in the future. So let's start with part 1 of the special characteristics of the Archimedes drive. And this will all be about the effects of traction on precision, noise, and speed. So you have seen this slide before a couple of times. And this is how precision is defined in gearbox industry. And for the Archimedes drive, I can say the stiffness is higher than any else, and there's no backlash, and therefore we have the most precise system in the industry. To illustrate it, a movie from our website where you see the smooth rolling with continuous contact and the gears rolling on the other side with the backlash here. And in my mind, I hear the cling, cling, cling when it goes like this. And also when it continues rolling, it slides the... And next to the sound, it also generates heat. And therefore, the difference between these two systems is more than just that backlash. So let's also talk about the sound I was just talking about. And people often don't care too much about it, but if they do, they typically look to the amount of decibels. This is not a linear scale. If you add 3 decibels to something, it's twice as loud. So a difference of 15 decibel would mean that you're 32 times as loud. And, we found an application where they actually care about the sound, and that's wearable prosthetics for prosthetic limbs. Because if you're so loud that you can't have a normal conversation, people won't wear it. So this company we work with, they wanted to test the sound. And in the chamber, they found out that their Delta 15 only produced a maximum, so not the average, of 50 decibels. And this is the equivalent of moderate rainfall. And is somewhere between, and is more silent than that normal conversation. They compared it to a strain wave gear they were using. And at the peaks, that was actually 65 decibels. So as I just explained, that's 32 times as loud. And to give a comparison, it's somewhere between normal conversation and your vacuum cleaner. So people are not happy with it. But that company looked for more. They recognized that people also care about the pitch. If you have a high noise, that's very annoying. Well, and that is what a strain wave gear had. Well, if you have a low zoom like the Archimedes drive, it's actually way more pleasant to the ear. And therefore, purely because of this noise, they want to work with us. But also in other industries, this is important to not only look at the decibels, but also the pitch. Because cobots are now working next to people, and there this can be very relevant. All right, let's go to the next one, and that's the maximum speed. And maybe you don't see the relation to efficiency and heat, which I just talked about. But if those gear teeth slide over each other, or if something rolls, a drive will heat up at a certain point. And, the scale over here is not exact because things get interesting around 70 degrees Celsius or 160 degrees Fahrenheit. At that moment, lubricant stops doing its work. And if you even go further past that, it will burn. And we speak from experience because our traction fluid burned at an older design when we weren't that good yet. And here you see the ashes of that fluid. But by now, we know better, and we have tested a Delta 15 that went all the way to 8,000 RPM. This is from a brochure where we compared it to the brochure values of the strain wave gear and the precision planetary. But this is not the whole story, because we only promote the data we actually know, and 8,000 RPM was just the maximum speed of the motors we have in our test facilities. But what we did do was measure the temperature at that moment, and we only measured the temperature of 40 degrees Celsius, which means there's still a range of extra speeds we can go until we're at a max temperature. And where can we go? We don't know. But what's very promising is this IMSystems drive we spoke about more often. This one was able to go at 75,000 RPM, 10 times of what you see on the left. And I have to be fair, it only lasted for 1 hour at this speed, but it was not because the lubricant stopped working. That was because of metal fatigue in that design, and it just started to wear. So, I hope you now have a better understanding of the differences between traction and gears and how that influences the noise, the precision, and the speed. Next time I will go into torque versus life and also see how that relates to weight before we can give you a complete overview of the comparison in properties between the Archimedes Drive and conventional ones. Thank you for watching. If you have a question, please leave them below, and I hope to see you in the next class.